Hello everyone, my name is Dhaniel, and in this video I will explain about calculus week 4. It's about convergent test. The number 4, it's 2 over 3n plus 5 with n start with 1 to the infinity. In this case we use integral test. So we change it to the integral form 1 to the infinity 2 over 3n plus 5 dx. So and change the infinity to b, and then we change the n plus 5 with u, and so 2 over 3 we move 2 over 3 to the 5, 2 over 3 integral 1 over u du. So integral 1 over u du is ln u, it become 2 over 3 ln u, 2 over 3 ln u, and the u will become n plus 5, so 2 over 3 ln n plus 5, and then we change the b to, we change again to b to the 1 to the b, and 2 over 3 ln b to the b plus 5 minus 2 over 3 ln 1 plus 5, so it becomes 2 over 3 ln b plus 5 minus 2 ln 2. And how do we get the 2 ln 2? So 2 ln 2 is 2 over 3, we know the 2 over 3 ln 1 plus 5. 1 plus 5 is 6, so we divide 6 by 3, so it becomes 2 ln 2. And then in this case, we change again the b with infinity. So the 2 over 3 ln b plus 5 minus 2 ln 2, it will become 2 over 3 ln infinity plus 5 minus 2 ln 2. So the infinity will become, infinity minus 2 ln 2. So it will become infinity. So it will become divergent. And then number 18 is n plus 2 over n plus 1, with n is equal to 1 start with 1 to the infinity. In this case we use integral test again, but in this case we change the u with n plus 1. In this case the u is n plus 1, so it become u of plus 1 over u. So the why we get u plus 1? So u plus 1 is, we know that u is n plus 1, so if we change the u with n plus 1, it will become n plus 1 plus 1, and n plus 1 plus 1 is n plus 2, so it's still the same plus n plus 2. So after this we divide it by u over u plus 1 over u. So u over u is 1 du, integral 1 du plus integral 1 over u du. So integral 1 du is u plus ln u. And then we change again the u with n plus 1, so it become n plus 1 plus ln n plus 1. And then we change again the n with b and 1. So it will become b plus 1 plus ln b plus 1 minus 1 plus 1 plus ln 1 plus 1. So it become infinity minus 2 ln plus ln 2, and infinity minus 2 ln plus ln 2, it will become infinity, so it become divergent. And then number 37, 1 over n to the power of b with n start with 1 to the infinity. In this case we use p series test. So what we need is, we just need the denominator. So the denominator is n to the power of p. So n to the power of p is, so we just need the p. So we just, the p is the p. So we know that p is 3.14. The value of p is 3.14, and we know that 3.14 is bigger than 1. So it means that p is convergent. And because p is convergent, so it means that this case too, 1 over n to the power of p is convergent. And then number 37, 3 over n to the power of 5 over 3. In this case we can still use the p series test. So we need to type the p. So p is 5 to the power of 3, and we know that 5 to the power of 3 is bigger than 1 because it's 1 point, 1.6 and so on. And then P, so it means that P is convergent. Because P is convergent, so it means that this case also is convergent. The 3 over n 5 to the 3 is convergent. And then the 1 over root n to the power of 3 plus 1 with n sub with 1 to the infinity. In this case, we can use direct comparison. So in this case, we need to find the an and bn. So the an is still the same form, 1 over the root n to the power of 3 plus 1, and bn is 1 over root n to the power of 3. In this case, we can use the bn as and use the p-series test. We change the root form first. The root form, we can change it to x to the power of 3 over 2, and then we got the p is 3 over 2. So 3 over 2 is bigger than 1 because 3 over 2 is like 1.5. Yeah, 1.5, and 1.5 is bigger than 1. So it means that convergent. Now, because bn is convergent, the 1 over root n to the power of 3 is convergent, so it means that an is convergent also. And then number 10 is n to the n cos n plus 2 over the power root n with n sub with 1 to the infinity. And in this case, we use direct comparison again, but in this case, it's different from before. Before we used p-series test. In this case, we don't need to p-series test. What we need is first we need to define an and bn. First, yeah, it's still the same as the comparison. The an is still the same form as before, the cos n plus 2 over root n, and the bn is cos n over root n. So we not include the plus 2. So we know that cos n plus 2 over root n is bigger than cos n over root n because it's the plus 2. So it means that it will be bigger and bigger than the cos n to the over n. So it means that if an bigger than bn, so it means that the case is divergent. And then number 20 is 2 to the power of n plus 1 over 5 to the power of n plus 1 with n sub with 1 and to infinity. So we use limit comparison. For different from before, we use limit comparison if the direct comparison can determine, so we use it. First, it's same as direct comparison. We need to find an and bn. It's same as the number before. So the an is the same form as before, as the t2n plus 1, 5 to the power n plus 1. But in bn, we not include plus 1. So it's just 2 to the power of n over 5 to the power of n. In this case, we divide it, the an divided by bn. So it will be 2 to the power of n plus 1 over 5 to the power of n plus 1 divided by 2 to the power of n plus to the power of n over 5 to the power of n. So we know that if we divide it, so it means that we times crossing times. So it will be 2 to the power of n plus 1 times 5 to the power of n, and then it will be 5 to the power of n plus 1 times 2 to the power of n. So it will be crossing. And then we got this form, 10 to the power of n plus 5 to the power of n over 10 to the power of n plus 2 to the power of n. And in this case, we just need to factorize this, and then it will become this. Factorize it with 10 to the power of n, so we get this form, 10 to the power of n times 1 plus 1 over 2 to the power of n, and the denominator is 10 to the power of n plus times 1 plus 1 to the power 1 over 5 to the power of n. In this case, the 10n is removed, so it will become like this, and we change the n with infinity. So n to the infinity, so it will become 1 plus 0 over 1 plus 0, so it will be 1, so 1 is convergent. And number 18 is 5 over 4 to the n plus 1. And then we can use ratio test. It's same as a limit comparison. But there is a little different from the limit comparison. The difference is this. First, we need to define an plus 1 and an. An is the same form as this, but an plus 1 is 4n for the power n plus 1. So what the difference is the denominator 4 to the power n. The difference is right here. And then we divide it, an plus 1 divided by an. So the 5 is gone. And 4 to the power n plus 1 divided by 4 to the power n plus 1. We will become we will change the 4 to the n plus 1 will be numerator, and 4n plus 1 will be denominator. And then we factorize it again like before, but now we factorize it with 4 to the power n plus 1, so it become 1 over 4 plus 1 over 4n plus 1, and then so on. It will be 1 plus 1 over 4n plus 1. And then we remove it and get this form 1 over 4 plus 1 over 4 power of n plus 1 over 1 plus 1 to the power 1 over 4 to the power of n plus 1. And then we change again with n with infinity. So what we got is 1 over 4 plus 0 over 1 plus 0. So it will become 1 over 4. So 1 over 4 is convergent. Okay, I think that's all for this video. Thank you for watching. See you next week.